One.
Welcome, ladies and gentlemen. Have you ever wondered what happens if you're solving a triangle,
I thought you were going to say
a right triangle, and you only knew the 90-degree angle and maybe like two sides? How would you find the other angles? You know that those other two angles are complementary to one another, right? I mean, let's draw a triangle.
I thought you were going to say...
No, I didn't, though. No, I didn't. No, that's not what I said. So let's say, what if I only knew that it was a right triangle, so I know a 90-degree, right? And let's say I also knew that, I don't know, let's say this was, let's say this is 6, and this is, I don't know, 2, something like that. All right, and let's label our angles. So this will be A, B, C.
Wow.
And let's say that my direction said to solve this triangle. This means I'm looking for all information about it, all right? Everything. So, I mean, I think you guys would be like, oh, this is easy. I could do Pythagorean theorem. And you would be correct about the Pythagorean theorem part.
But not about the solving part.
Oh, actually, I just set up Pythagorean theorem wrong because it would be, it'll a squared plus 2 squared equals 6 squared. Yeah, hypotenuse always has to be the right-hand side.
2 squared is 4, and 6 squared is 36, so subtract the 4 to the 36.
That's not an equal sign, that's a plus sign. Plus 4 equals 36.
Subtract the 4, which you did not do.
And then a is root. Well, yeah, 36 minus 4.
Why
I didn't write
doing
it.
the changing the colors and subtracting it like you usually do?
This is Pythagorean theorem.
Yeah, but you usually do
root both sides. Square root of 32, 16 goes into it. Square root of, that's 4 roots of 2 is what that would end up equaling after doing a little bit of work. So 4 square roots of 2 is that side. However, I don't know what angle A or angle B are. How do I find those angles? Well, this is what we can do. From angle A's perspective, let's talk about angle A. What side is the 2 here? What side is the 2 here from angle A's perspective, guys?
From angle A, it's the
It's the adjacent leg, right? The legs are... Here, friend, red hat, come on. Man.
Oh, I thought it would be the opposite.
And 6 is the... hypotenuse. It's the hypotenuse is always opposite the 90-degree angle. Adjacent leg because it's touching angle A. Opposite would be not touching angle A, so it's furthest away.
That.
So this is the adjacent to angle A, and 6 is the hypotenuse. So what trig ratio compares those two things? Cosine. So I'm going to say that cosine of angle A is equal to 2 over 6. Right? Do you guys agree? Right, I've merely just set that up like I would normal. Right, so nothing too crazy. Right? So now the question is, well, sure, I could reduce 2/6 to be, 1/3. So cosine of angle A is 1/3. So in this case, I know the ratio is 1/3, but I don't know the angle. Now, I could technically try looking up at my chart and figure out, is there a 0.3 for cosine somewhere in that chart, and what angle would be true for that?
Oh,
I don't know if there's a bingo. But it turns out...
Right there, look. What?
Yes.
Nope, it's not enough.
I don't know if that's a true bingo.
That's not.
That might be a bingo.
That might... It's... Yeah.
Should we get some zoom action?
No, it's subtle. So anyways, how would we get A by itself? It turns out there is a way to undo cosine. Now there's no such thing as dividing both sides by cosine, but what I can do is take the cosine inverse of both sides.
So how you guys do like
Why can't you divide by cosine if it's just a number?
Cosine of an actual angle represents a number.
Oh, okay.
But to get A by itself, I have to cosine inverse both sides. So I will get A is equal to the cosine inverse of 1/3. And now, understand the cosine inverse. Inverse functions, the idea is they undo what another function did. So let's think about the regular cosine function. For the regular cosine function, you give it an angle, and it gives back a ratio. The cosine inverse, we're going to give it a ratio, and it's going to give back to us an angle. So let me show you how I can do this actually in the calculator rather than on the sheet. So I'm going to turn this calculator on, and
Why don't you use your digital one?
because I didn't feel like starting it up. So notice sine, cosine, tangent buttons. Right above those are sine inverse, cosine inverse, and tangent inverse. So I'm going to hit second cosine, and I get cosine inverse on my screen. So the input that this is expecting, it's expecting a ratio, and it's going to give us an angle. All right, so I'm going to do 1 divided by 3 and close those parentheses.
Do you have to close the parentheses?
Yeah, in this case, I think we might. So cosine inverse of 1/3 happens to be about 70.53 degrees. Okay? So it undoes what cosine do. So A is equal to 70.53 degrees. Now, granted, we could find angle B by just subtracting this from 90, but let's look at angle B's perspective. All right. From angle B's perspective, I'm going to do this in green. So angle B is a different measurement than angle A was. And from angle B's perspective, what is 2? What side is that? That's the opposite, right? And from angle B's perspective, what is 6? The hypotenuse. So what trig ratio compares opposite and hypotenuse for angle B? Sine. So I'm going to say sine of angle B, whatever it is, must equal 2/6, right? Opposite over hypotenuse. So to find B, I'm going to do what to both sides, would you guess? Sine inverse. Sinverse. Sine inverse. So sine. So that's not read as, that is like a -1 exponent, but it's read as sine inverse. And that inverse notation, I think we might have seen before in previous classes when we were dealing with inverse functions. So B is equal to the sine inverse of 1/3. So now what does sine inverse say? It says, give me a ratio of opposite to hypotenuse, and I'll give you the angle, right, that has that ratio. So it undoes what regular sine would have done. So I'm going to hit second sine, and I get sine inverse of 1 divided by 3, and enter 19.47 degrees. So the idea is that we can now find missing angles using these sine inverse, cos inverse, tan inverse functions. All right. So all you do, it's all about the setup, right? If you can do the setup, you can solve these, right? So figure out from that angle's perspective, what sides do we know, what ratio compares them, right? So cosine of A is equal to 2/6, right? Blah, blah, blah. And solve it from there. I think that's all I'm going to record for this since it's a short period right now. And then I might have you guys practice a couple problems before we go. So 8-minute video, what do you know? Bye, Internet.